Under our new definition of sine, cosine, and tangent, sine is the y-coordinate of a point divided by its distance away from the origin. Cosine is the x-coordinate of a point divided by its distance away from the origin. And tangent is the y-coordinate divided by the x-coordinate of the point. We have certain traditions that are going to be followed here in order for this definition to work. This definition requires that we set up the angle in a specific way. So just like there's a tradition that says when you look at a map, north points up, unless there's a compelling reason to do otherwise. When you make a clock, 12 is at the top of the clock. There's no reason it has to be that way. It just is. That's the tradition that has been built, and we continue to use that. We are going to have a certain tradition that we will use when putting these angles on a graph. And one of the things that is true is that one of the two sides of the angle, every angle has two sides, one of the two sides lies along the positive part of the x-axis, just like this. So this is going to be one side of the angle. And it's always on the x-axis, and it always is on the positive part, the right-hand part. Also, the vertex of the angle, the corner, is always going to be at the origin. So we've got it lying along the positive x-axis, we've got the corner at the origin, and then we have another part of the angle that can come off in different directions. We could come off over here, we could come off like this, like that, we could come off down here, or even down here, however we choose to do it. And so I'll use that right there. Okay, the last little bit of tradition is that the definition of our angle is always going to be measured from the positive x-axis to the other side in a counterclockwise direction. So we're going to start here and we're going to go counterclockwise until we get to the other side. If that means the angle ends up being more than 180 degrees, so be it. We're going to go in a counterclockwise direction. So this one here, well, that would be 90 degrees. Let's write this up here. That would be 90 degrees. This would be 180 degrees. If we went down to here, that would be 270 degrees. And if we completed the circle, we may have started at 0, but we get back to the same place when we get to 360 degrees. So this angle here may be something like 210 degrees-ish, maybe. I'm just estimating. We could find out exactly what it is, but I'm not worried about it. It's not really 210, but it's fairly close to that 210 area. It would be somewhere between 180 and 270 if it's going to be in this quadrant of the graph between the negative x-axis and the negative y-axis. This quadrant, that's got to be between 180 and 270. We measure in the counterclockwise direction. And sometimes we're going to want to say, you know what, to get from the beginning to the end, I actually want to start over here, and I'm going to go all the way around the circle and then go where I want to go. In which case, now our angle is more than 360 degrees. That's okay. Might be 360 degrees plus another 210. So something like 570 degrees. Or whatever it actually is. We can go around the circle 10 times and then go here. That's fine. However many times we want to go around the circle, we can do it. Most of the time, for the time being, we're going to just go this get there in the shortest distance possible in a counterclockwise direction, so our angles will be less than 360, but that's not always going to be true. Okay, so what if we do want to go, for whatever reason, we do want to go this way. We want to start here and end up over there. Well, let's make believe again that this angle coming this direction was 210 degrees. Then obviously, because a circle is 360, if the red angle, the counterclockwise angle, is 210, then the clockwise angle that's drawn in blue there must be 150, so that the whole thing is 360. But we want to make it clear that we went in the clockwise direction. We went in the other direction. So we call this a negative 150 degrees. Positive 210, negative 150, they end up in exactly the same place. If we wanted to do a line that comes off like this and say this is a this in the counterclockwise direction is a 105 degree angle. We could also call it a negative 255 degree angle. 105 plus 255 gives us 360, but because this one comes in a clockwise direction, we call it negative. That's just the rule that we follow. Clockwise is positive, counterclockwise is negative. All right. One more thing. Here's an angle. If I do the counterclockwise positive angle that gets there, the point down here at the end has some coordinates, x and y. Based on where I am over here in the third quadrant, I'm to the left of the y-axis and I'm below the x-axis, to the left and down, then we know that x and y are both negative numbers. Let's write that down. In this quadrant, in this section where we are to the left and down below, x and y are both negative numbers. X is negative because it's to the left, y is negative because it's down below. Well then, what's that say about sine, cosine, and tangent? Sine is y over r. Y is a negative number. So I'm just going to put a little minus sign for the y because it's some negative. R is this distance. That distance is never going to be negative. It's a distance. It's not a coordinate, it's a distance. And so that distance is always some positive number. It's the radius of a circle, essentially. It's the distance away. So that's always a positive. Well, if sine is y divided by r, y is negative, r is positive, sine must be a negative number. How about cosine? Cosine is x divided by r. X is some negative number. I'll put a little minus sign for that. Divided by r is a positive number. Cosine must be a negative. How about tangent? Tangent is y divided by x. Y is negative. X is negative. Negative divided by negative is positive. Tangent must be a positive number. Think about what that what has to happen for each of those in the other three quadrants. If x and y change when you move into these other quadrants, what does that tell us about sine, cosine, and tangent in these other quadrants? That's what I want us to think about for tomorrow.